Swayam Prabha. Digital India. Educated India.
Good morning, everyone. In this talk, we'll see about job scheduling. So, we all have been using our HPC systems for the past few days, and so the way we have accessed, so it was like we are accessing like our personal machines. So, in our personal machine, like we submit the job directly, and so whatever settings we have to do directly, we do everything on command line, and we like run our programs like that, and we see output there itself. We run everything we do on the command line itself there. But when we go to a multi-user environment, and where the resources are shared across, and there we have like distributed resources. So this approach is not very efficient and not feasible also many times. So because of which there is a mechanism through which we should submit or we should run our jobs. So this is about job scheduling. So what is a job? A job is not only our executable, but it's like all the resources or like all the data, all my environment variables, everything which is required to make the job run. So that is a job. Then when we use HPC systems, so which is shared across users, so it's always preferable or sometimes mandatory also to use it through job scripts. So that is, we define all our execution thing inside a script, which we call as job script, and we define our resource requirements, like our wall time requirements, our number of CPUs requirement, memory requirement, and such information, relevant information. And we define our environment variables there, whatever variables like setting number of threads or whatever. And then we use this script, we submit it through a scheduler, and then like whenever, so it goes into a system, scheduling system, and whenever like the resources are available, so that job will be run there. Now, there is a term job size. So job size refers to like what number of nodes or what amount of resources that we want to use. So generally in terms of number of nodes. Then job length. Job length is the amount of time that we require it to run on the given system. Okay. So basically there are two modes of two possible modes of job execution. So I hope I am audible. Right? So one is the interactive mode, one is the batch mode. So the interactive mode is like as we are using our personal computers, like we go to a command prompt, we set our environment variables, we run our job there itself, we wait for the output to come or we redirect it, and so on. But this is not a very efficient manner way, because for example, we are doing hands-on. Let's say we have SSH to some node, we have gone there. Now we are running our job there. So we run our job there for a small amount of time, and most of the time, like we spent like setting our environment variables, or like just viewing the output and so on. So this would lead to improper or underutilization of those systems, right? So we must have some mechanism in which we well define our job, and we submit it so that the system is engaged only for the time it actually requires to run that job. Right? Then many HPC systems, they don't have actually interactive access. They don't allow that. So it's simply because of these reasons to have to minimize the underutilization of the system. Then if at all we are allowed to interactively access the system, so it's not necessary that we immediately get the required resources. We submit our interactive request, and then the resources, so then the request may get queued, and we may get the required resources at some point later. But the user may not always be present there to run the job. So once the resources are allocated, they may be idle because the user is not there. So it has a lot of potential to get the system underutilized. Then a standard way to use the systems is the batch mode. Batch mode means we run our jobs in background. That means, like, say we have defined our job and related environment variables, and we submit it to the system. And whenever the resources are free, that execution will happen. So the resources will be engaged only for the time when the job is executing on it. So they won't be idle for it. So most of our jobs, we know they are for multiple nodes. Generally, this is the case. So like in interactive mode, if we take multiple nodes, and let's say we are starting our job or we are doing some other activity, so that can waste a lot of resources from these nodes, acquired nodes. And in case of batch modes, so there are generally they are provided exclusive access to the system. So we should try to use the full system available to us. That is the case. So in most of the systems, because what happens that let's say if multi-users, they are allowed on a shared node. So what happens that it's not guaranteed we'll have their performance in a deterministic way, right? Because they'll be sharing CPUs, caches, they'll be sharing memory. So these all can lead to degradation of performance of both the jobs, so which is not intended. So generally, the resources are provided at the node level granularity. So we must always strive to use the resources within all the resources within a node. So how do we make use of system, or how do the system controls users' jobs? So the system, which is the scheduling software which is there, is called batch system, which comprises of workload manager, which is whenever we define our job, so it's the job of this workload manager or job is scheduler, which identifies what resources the given job requires, like how many number of CPUs, GPUs, memory, and so on, what it requires. So now there can be multiple partitions, we can say, within the system based on the resource attributes of the system. So let's say we have CPU only nodes, we have GPU nodes, we have high memory nodes. So some nodes which have very high memory for certain application requirements. Then there may be nodes with some other high frequency nodes can be there, and so on. So then nodes with different CPU architectures can also be there, like a previous generation, current generation, and so on. So they are part of the same HPC cluster, but they are partitioned into logical domains, which we can call as, so in different batch system contexts, they are called differently, like they can be called partitions, they can be called queues, and so on. So it's the workload manager which identifies like what the user has requested for, what queue and so on. Then there is resource manager. So the resource manager's job is to identify like what resources are present in the system. So it gives a complete view of the system. It has all the information of the system, like the partitions available, the nodes available, their configuration and all. So whenever we submit our job, so this workload manager identifies the job requirements. It talks to resource manager, and like whenever such resources, so it talks to resource manager. If resource manager sees and if it gets to know that the amount of resources they are available on the system may not be immediately, but such amount is available, so my job will be valid. Otherwise, it will immediately say that the job is exceeding or the system does not have that resources. Then at every compute node level, there is an execution manager. So, so our workload manager, once like it acquires the resources, so it will send the job to execution manager, and the execution manager will like spawn it on their local nodes. So there would be daemons or there would be background programs which would be running on these execution nodes, and so these are taken care by the execution manager. So the job scheduler or the workload manager, it is responsible for receiving the job script, and the job may not be executed immediately because there are multiple users, and the job may get queued if the resources are not available. So there are several job scheduling policies, and most of these systems, they have a combination of these scheduling policies. They don't have just one. So a very simple policy is FCFS, first come, first serve. So which says that, let's say I'm a user and I have submitted my 10 jobs. So, and system is free and I have submitted my 10 jobs and the resources are free. So all my 10 jobs will be allocated on the system. Now let's say another user comes in and submits the job. So if the resources are not free, so like my job will be running on the system. Or let's say the second user comes with a job requirement of say 10 nodes. We have 4 nodes free on the system. The second job requirement is 10 nodes. Now a third job comes with say requirement of 4 nodes, right? But although the system is having 4 nodes free, but it will not schedule the third job right away. It will, because it is first come first serve, it will wait for the second job to complete first, acquire those 10 nodes, and then only it will allow the third job to finish. So, so this is not an efficient mechanism. So this can be like managed by backfilling policy, in which like the scheduler has intelligence to identify like what jobs can be, what jobs lower in the job queue, which can be fit into the system ahead of higher jobs in queue, and without like delaying the prospect of scheduling of lower jobs, right? So that is backfilling. Then fair share. Let's say, so we hear this term a lot, like in our mobile data also and everywhere. So where like if we, so like in case of our mobile data, we get certain amount per day. So though it is unlimited, but certain amount we get at a higher bandwidth, then we get it at a limited bandwidth after that. So similar is the case here. So if I use a lot of resources in a small amount of time, then for extended period of time, the priority for me would be reduced. So I'll have lesser priority than the jobs which have used the system less over this period of time, right? So, so this like allows the system to be made available across users, so that one user, like, he keeps on, he has put a lot of jobs in the queue, he has several jobs in queue, so that should not hamper the prospects or not starve other jobs from getting running, right? Then preemptive, so wherein like priorities are assigned to jobs. So these can be assigned through individual job level, or they can be assigned to queue level or partition level, wherein jobs associated with those queue or partition, they'll be having higher priority. And so once they come, so a job running on the system may get preempted, provided like the system has mechanisms to save the state of the running job, so that it can restart it to that point or near point in its execution, last execution later on. Okay. So job queues, so they are based on various policies and features of the system. So policies, it can be like within a institution or department, there can be several projects, several groups of people. Jobs can be, specific jobs can be created for specific groups of users and so on. Then jobs can be based on the types of resources of the HPC system also. So like there are various jobs in the system, and when a user of the HPC system may not be allowed for all kinds of queues, job queues. So he or she may be allowed for certain kinds of queues only. Now, then you can have a queue for your like interactive access. So there can be a different queue for that. So let's say we have a 1,000 node cluster, maybe 10 nodes out of this cluster, they are like made available only for the, they are made available for the interactive access. The other nodes cannot be accessed in interactive mode. So these 10 nodes can have a separate queue for them. And so interactive access is also important sometimes whenever like we require the need of debugging of our jobs. So when we are writing our, developing our own programs, so there like, though we have tested it on a smaller scale, but it's not necessary that it would work fine at a larger scale also. So in that case, we require it to run on a larger case, and if it gives problem, so it's not always like the issues, they are captured well through batch mode. So sometimes we have to require to debug the application. So we have to interactively access. We have to actually go to the nodes and see the interactive, see the like run the job interactively there. So for that, like we require interactive access. So when a user has to submit a job, he or she must select a queue for that. And batch system. So batch system is a collection of this scheduler, like our workload manager, our resource manager, our execution manager, and all the commands that provide handle to the users to like query the system or to get the allocation of the system. This is a sample job script of a scheduler called Slum, and on Shrestha that we have been accessing. So we have Slum job scheduler. Till now we have not used it. So it was I had reserved the nodes and had it had submitted a sleep command in a batch mode, because of which the nodes were allocated to me, and so user can directly log into the node. So once the node are allocated to us, so we can directly go to that node and we can see what is the usage of by our application, whether we have good percentage of CPU utilization, how much memory utilization we have, and so on. So this job script, we saw annotations in case of our OpenMP program. Similarly, you have annotations here. So this is where we have the batch resource or resource requirement specification or commands here. So now this represents the number of nodes in the system that we want. So this is the you can say the system administrator will define the resources of the HPC system. So these resources are defined generally at the node level. So you have information of a node, what resources are present within a node, and so the users also request at the node level. So though there can be possibility of accessing only a sub part of the node, but at least we'll have to specify one node to get even one core of it, right? Then we can specify how many number of cores we want for the node. So this will give me 10 cores within the node. Let's say I don't have exclusive policy in my system. That means multiple users can share a node. So in that case, multiple users, let's say I have 40 cores, so 4 such jobs can land on the same node in that case. Then I can specify my memory requirement. I can specify my time requirement. So this is hours, minutes, and seconds. Then my job name. And then I can specify job file name wherein my standard output, standard error will go to. So this %J will take the job ID. So whenever we submit our job, we get a unique identification with respect to that job, and so that we can uniquely identify the output of that job. That job ID would be, this job file would be named with this job ID. Then in Slum we have partitions which are equivalent to queue in other batch systems, and so I'll give you a demo in which you can see what are the different partitions, and we have to name one of the partition. And there can be a default partition also. If we don't name it, we can get the resources from that partition. Then these are some job environment variables like Slum submit dir. So the directory which we are working on, or from which we have submitted our job, right? So that path is captured in this variable, and generally it happens that wherever we have our input executive or all the dependencies of my program, so we run our job from there. So when my job gets actually running, so it will go to this node, this path first, so that it has access to, so it has all those input files in present there. Then we give our command here. So the number of processes can be directly will be calculated based on our request given here. So if we have, let's say, 1 node and 10 cores, so this value will be 10 here. If we have 2 nodes here, the value would be 20 here. Then there are lots of commands. Some are user level commands, some are system admin related or root privileged commands. So through which this batch system can be used. sbatch, this is the most commonly used command for our for Slum. So we create our job script as we had seen in the previous slide, and then we'll pass this job script to sbatch, and so that would get, our job script would get submitted. Then sinfo gives us the information about a summary about what nodes are or what resources are available on our system. Then srun is there. So srun is used to launch the job. So within our script, we can use srun. We can also use srun for interactive access. So when we use srun, so this will be integrated with our MPI implementations. So we'll directly use srun, and so that will be that would spawn our job. scancel to cancel our jobs, and job ID is the parameter to it, input to it. sq gives us what jobs are there in the queue and across different partitions for all users. Through scontrol, we can have finer details about the system, about the jobs, about nodes, and so on. salloc, so this will give us the interactive access, but will not directly land to the job. srun, if we are accessing interactively through srun, we'll land on the first compute node which is allocated. We can have multiple nodes allocated, but we'll land on one of the node, and from there we can make use of other nodes also. But through salloc, we do not land, it is simply allocated to the user. User has to SSH onto that, and he can run. Then saccount, so it gives the accounting information related to the usage by different users. So this is relevant because generally the users are not given kind of free access to the system. They have limitations in terms of CPU hours that they will be allowed to use. So there will be an accounting manager which will keep account of all the system, and there will be a account name related to every user. User has to give that account name while running the job. sview, it gives us a graphical display of running jobs, available nodes, and so on. So some more features, like we can have job dependencies, wherein we can, let's say I have a pre-processing requirement, then main processing. So I have submitted both the, so pre-processing may not always require huge amount of resources. They are not always running in parallel, or they run they are not that scalable. So we'll have fewer requirements, resource requirements for them. They may be serial in nature, but may take huge amount of time. So in that case, we should not be doing within our job script. We are doing pre-processing also, and we are doing main execution also, and we have acquired the whole lot of resources for that. So for that, we can have make use of dependencies. So we'll submit the pre-processing job, and then we can while submitting the main execution job, so we can specify the dependency here. So whether let's say we put after OK here, so that means once my pre-processing job is completed, then only my main job will start. And we have to pass the job ID of the pre-processing script. And then singleton, it is used we have several jobs with the same names, so it is used for those. Then we can fire multiple jobs through single script. So we'll create an array of jobs and they'll be fired. So this can be required doing some benchmarks on the system. You have set of nodes, 8 nodes for each benchmarks to run and so on. So you can run them in an array rather than running them individually. These are some of the well-known or widely used resource or scheduling software. Slum is one of the most widely used. So if we see the top 500 supercomputers, so 60% of them, they are using Slum as a resource manager. Then PBS Pro, so this is the professional version of PBS, portable batch system, and there is a open source version of it, which is called Torque, but they have they are not doing it active development of it right now for the Torque, so it is quite old now. But the PBS Pro is there on it's a commercial software, but Slum is open source and freely available one. Then load sharing facility, it's another scheduler or scheduling software, load leveler and Condor. These are some of the references. Any questions? So I'll give some demo and then I'll give you a sample script which you also submit, because the interactive way makes as of now you all have common user, but that is just for the workshop. But in real environment you all have separate users. Now once a user has acquired a node, so other users interactive node also, so that would not be available for batch system. So it would lead to underutilization. So in that case, we have to go for batch submissions. So this is a sample job script, or is this visible? So here you have number of nodes, then number of tasks per node. So you must know this, if you give more number of nodes, it can be in queue or it can throw error also. Then the time, so here I have requested for 50 minutes, 20 seconds, the name of the job. So it's always good to give our job a name, so that whenever we have multiple jobs or so, and whenever we are displaying, seeing that information, so we can immediately understand which job is running or which has completed. Then error and output and partition. So this is commented right now. Then we have this CD submit there. And so here I'm just doing some stuff. I'll cover that a little later. And now I am running an MPI job here. Right? So let me submit the job. Okay, so before submitting the job, let us see what jobs are running on the system. So these are some of the jobs which are running on the system, and these are their job IDs. Then, like what partition? So it has GPU-based nodes, so they are named as GPU. Then the only CPU-based nodes, they are named as CPU. This is the name of their jobs. And if nothing name is given, it comes as bash, user, and the job state of the job, so running or in completion state, and the time it has been, it has like spent in running, and the number of nodes the job is using, and on which compute node it is on. I'll cancel this job. Okay, so now I'll submit the job script which we had seen. So its job ID is this. I think the output would have been already generated. So this is the output that has come from it, and now, so this output was on single node. We had taken a single node, and yesterday also we saw like how we can spawn our job on multiple nodes, right? So, so there are various ways of doing it. One of the ways provided by, so user doesn't explicitly specifies that. It's the job scheduling system itself would manage it, or my MPI itself would manage it. Let's say I have allocated certain number of nodes. So my MPI is so if the job scheduling system is aware of that MPI implementation, that means if it is integrated with that, so that MPI system implementation would also be aware of like what nodes are allocated to us. So it may spawn the jobs on them, and how it does, that depends upon varies. Like it can do like in a cyclic fashion, one process on each of the nodes, and then again in a round robin fashion, or it can like give first exhaust all the processes of a single node, and then it will go on to another node. So if user wants to have a finer control of that, so we can do it through some scripting mechanism. We write certain commands, certain scripting commands to do that on our own. So for example here, when I have requested the number of resources and number of nodes and number of cores per resource per node, so I'm whenever my job gets scheduled, so I have that many number of cores or processors available to me. So that value can be retrieved through this environment, job environment variable, slum and tasks. And like I'll just simply run a hostname command here to find like what different hosts are allocated to me. And so what it will do is like I have asked n tasks per node as 40, right? This is 40. So it will give me 40 entries in this for a given node. So let's say, so yesterday we had seen how we were running on multiple nodes. We had created a host file in which we had specified the name of the host, which was like corresponding to the IP address of the host. So the name of the host followed by the number of processes that we want per host, right? So we had given that in an ordered way. And similarly, we are doing this through scripting now. So the output of this, so when I run it with hostname is a Linux command which will give us the name of the host wherever like this command runs. So it's not an MPI program. Now I redirect it to a file, and then I do sorting, and I found the unique of that, and I create another file from it. So now I can say how many number of processes we want within that per node. So this is particularly more required when we have hybrid kind of requirement, when we want OpenMP and MPI also to go hand in hand. So in that case, we can control like how many processes would be running on each node, MPI processes, and then we also define like what is the number of threads, OpenMP threads that I would want per MPI process. So it's our responsibility to see that we do not oversubscribe or underutilize the system. So here, again, like we have created this job script, and in this job script, each line we have appended with number of some number, right? So this will correspond to the total number of MPI processes that would be run onto the system. So let's say I use 2 nodes here. So what will happen that I'll have now, after this, I'll have unique entry for every node, and I'll say I want 20 processes on each of the 2 nodes. So when I will run with 40 processes, so 20 processes will go to one node, 20 processes will go to another node. Now, for each of these 20 processes, I can have 2 OpenMP. I can have more, but that will kind of oversubscribe it. So now, we can pass the information about our OpenMP thing in the command in the MPI exec command line itself. So there we can pass it as environment variable, like we can give it like this. So right now the program is not using OpenMP, so we'll not have the threads printed there, but we can make use of it like this. So we have the this hybrid program, MPI and OpenMP. So you can try it that you run certain MPIs per node, and these MPIs create OpenMP threads within the node. So so machine file we had seen yesterday, and now we have passed this job list which we have created, and we are passing it element parameters. Here I am setting OMP num threads to 1, and then the number of MPI processes. So this also should be captured in a variable. It should be generic, because so that we don't always have to change the script or change it at this place. We can change it at the top level only, and we can like have that value incorporated here. So here I am finding out how many number of MPI processes I want to launch. So I have total these many, this multiplied by this many number of cores. So this value comes in slum and task. Now I want to run half of them. So I'm only running 20 MPI processes per node. So I'll pass this here. So I have got this 2 nodes, 13 and 14. So the job is completed. Job ID is 7101. So the standard output comes in this, and here we have MPI ranks, and so we'll see the first 20 ranks would go to CN13, and the next 20 ranks they'll go to CN14, right? So this is this also gives us a way to control the placement of our MPI ranks depending upon like how to what rank is talking more frequently with other ranks. We can control that also. Then in certain applications, you may require varying number of OpenMP within MPI. So certain MPI processes, they'll run with certain number of threads, other MPIs will run with other number of threads. So that also can be controlled through it. So you have to provide proper job scripting for that. So you know that on how many nodes or with how many ranks you want to run so many threads and so on. So you have to provide it explicitly. So let me see if I have a job for that. Don't have right away. Okay, so I'll show you a CPU and a GPU job. So in which how we can have finer control. Like say we have 2 GPUs on a given node, and so user can allocate only one of it, so that other user can also allocate the other GPU if I want to use. So that can also be specified in this job scheduling system. So there is a application called NAMD, which is a molecular dynamics application. It's an open source application, and so there is a script for that. We can ignore the other part of the script, and as like I had mentioned earlier, that this is the way like in this I am creating a host file, and then I am doing module load. So in so one of the we have been seeing while we are running our programs that we have to put ./a.out or name of our executable, right? If we are not putting that /, it was giving error because there are certain environment variables like path environment variable, which gives the path where our executables are or commonly used commands are. So that path information, that path has values for those locations from where those commands are coming. But if I have, let's say I have an application installed on the system, I know that application is installed. So one way is like I must know where the application is installed, so that I'll have that path information, and I'll pass that. I'll need to set that path in my environment, or like I can do it in my bash RC file, or I need to pass it in my command line execution. Another standard way is to do it like they are available as module, which is a Linux utility, and we simply load it, unload it, and see information related to that. And so the paths of this particular module will be set in my environment. I can use that application now. Then I am running this application, and here I am doing like what GPU it will be using. So I am saying, so on this particular system we have 2 GPUs per node, so it will be using GPU 1 and GPU 2, means both the GPUs on the system. So the job's name is named CUDA, and it has gone to 2 nodes, GPU 00, GPU 02. We can SSH to the node and we can see it running. So the job is running. It is using, so we had run 2 processes per job, and these processes, they were using their own threads provided by the application. Then also we can see the GPU utilization. So here the GPU, 2 GPUs are there. So this is 0, this is 1, and 2 processes are running, one on 0 and one on one numbered GPU. This is the percentage utilization. This. Now, if I want to allow a user with only one GPU access, so that cannot run on, or if the user wants access to only one GPU, so that also can be specified. I'll cancel this one, and I'll take a interactive access to the system. So you see here, when we have taken it from srun, we have again landed to the same directory, right? So if we have to do SSH explicitly, we would have landed to the home directory only. So, and the environment from the login is also carried forward here. But when we do it with slawk, so that environment is not carried forward, and we have to explicitly do SSH to the node. Now I'll do the module load for the application. This is my executable. It is coming from this path. Now I have hit set. I can run it. So this is the format of the application. So it has nothing to do with MPI. So this is how application specifies it. Now the job, I'll open another terminal. So this is I am doing interactively. I have taken an interactive access. So we are using both the GPUs here. Now I'll terminate the job and I'll go out of this node. I'll take it with so GRES for generic resources. So here like CPU is defined as one of the resource, and I'll say that whether I want two of it or one of it. Okay, somehow not able to go. So okay, let me do through the script. Okay. So I'm requesting two GPUs. It is giving error. The job is giving error. Now let me request one, and it is running now, right? So I had asked for one. Okay. So this how like resources can be controlled, and then there are a bunch of commands you can use. You can like sinfo, it will give you information about the nodes available. Then scontrol gives you more information, like show nodes, what nodes are available on the system, what are their like resources on the system. Let's say this GPU 02, so cores per socket. So this, the like whoever is configuring the batch system, so he has to define these. So the batch system doesn't fix it on its own. So it has to be defined into the system. What is the load? So if we run a job, we'll see like if 40 cores are in used, it will say load of 40 or whatever like percentage utilization, average utilization is there, and so on. It also gives, okay, so this is the node information. Similarly, we can have information about jobs. So it will give us like from where the job was submitted, what was the name of the script, what were the contents of the script. So there's the last job. So it is giving this. This we had asked GPU:1. So there is a graphical interface also through which like we can see information about jobs, nodes, partitions, what queues are there, and so on. Yeah. So you can click on it, have more like detailed information about the same. What reservations are, so we have created a reservation for this workshop. So this is the one. So when we want to use the, so it is giving like the time start of the reservation like December 07 to December 10. Right? So to make use of this reservation, we have to get the reservation name. So like if the nodes are free, directly you all can go to the nodes, but let's say the nodes are not free, so there are a certain number of nodes reserved for AWS users. You can see the reservation information here, and this is the name of the reservation. So while submitting our jobs, whether through interactive or batch mode, we have to pass this reservation name inside the script or on command line, and we'll get the resources reserved. So these are the list of resources reserved, 01208 and so on. Now there is a sample script inside home apps, HPCS, AWS. So this is a sample Slum job script, and you can use it. The reservation is not put here if the nodes are not available. So I see currently the nodes are available, but if they are not available, you can make use of the reservation name. You can put it like as batch -- reservation equal to and give this name, and you will be able to access, right? So you can use like your hybrid MPI OpenMP programs to just see how you can run OpenMP and MPI on multiple nodes. Any questions? That's all from my side.